All right, so we learned about simple machines, and we learned how really it's all about the work. The work is going to be equal to this force times this distance, and we don't have to worry about that cosine of the angle just because the force and the distance are going to be in the same direction. And so therefore, it's going to be changing this. And what we're going to do is we're going to be able to use our simple machines to change the amount of force or distance that we're going to need. This is going to be very good for us. Now, why would that be good? Well, let's think about a type of simple machine like an inclined plane. Now, I myself, I don't have the ability to jump 3 stories high. I know that some of you guys probably have that ability. I just don't. I'm very, very weak. And so because of that, since I cannot jump 3 stories in one jump, I don't have that ability. They've made this new invention for us, which we call stairs. And stairs are really just a type of inclined plane. Okay? I mean, it's lots of like little jumps up and down, but really it's really just going to be an inclined plane. It's a type of inclined plane. Now, I don't have the ability to jump. I don't have the ability to have the jump straight up for 3 stories. I can't do that. Okay? I don't have the force to be able to do that. But I do have the ability. To walk up 3 flights of stairs. And so the force that I have here is going to be much less than the force of jumping straight up. Okay? So what I have done with this simple machine is I have decreased the amount of force that I need to input in order to be able to go up these 3 flights of stairs, which is very nice, but it comes at a price. What's the price? Well, the price is, if I were to jump straight up 3 flights of stairs, my displacement or distance would be very, very, very small compared to the amount of distance I'm going to have to go and walk up those 3 flights. That 3 flights of stairs difference, displacement, is going to be large. So what's going to happen is that in order to decrease my force, I'm going to have to increase the distance that I do that force. And that's okay for me. I'm all right with that because I could do a little bit of force over a long distance a lot easier than a lot of force over a small distance. And so some machines do the opposite, but most of the machines are really, really good at decreasing the force and increasing the distance that you're going to have to do. The work is going to be the same, though, either way, and that is huge to understand. The work on the simple machines is always, always, always the same. Okay, now we're assuming that there was without friction, and that's not always going to be the case. Next video we'll talk about with friction. But right now we're going to be talking about without friction. Okay, and if that's the case, then the work in is equal to the work out. All right, well, that's easy enough. So that means that the work in is going to be equal to the work out. Now, wait a second. We can go and use this equation for work. Work is equal to force times distance. And so, therefore, the work in could be also written as the force in times the distance in. And the work out could be written as the force out times the distance out. Now, what are we talking about when we say in and out? Let's go and understand this. The in is the effort that you do to the machine. Okay, so if you're talking about a pulley, it's what you are pulling on the machine. If you're talking about a lever, it's what you are touching on the lever. For this inclined plane, it is going to be, the input is going to be what you actually do. So in this case, I use the stairs, and so that's going to be the force for me, the input force, and the distance for me to go on the stairs. Okay, so that's going to be the diagonal section there. Okay, now, the output is going to be what the machine does to the load. So for this inclined plane, the output is going to be this section over here. That's going to be this section over here. What actually occurs from me going up the stairs. When you talk about, for like a pulley, for example, the output work is going to be not what you're pulling on, but what is being pulled up by the machine, the load that the machine is pulling up. When you're talking about a pulley, for example, a lot of times you push down on a pulley, that's going to be the input, and on the other side, the pulley goes up, that's going to be the output of the of the lever. So the lever you push down, and then the other side of the lever goes up. The side that goes up, that's going to be the output work. Okay? And so you could see how that works there. And if we use these ideas of force times distance, we get that the fin times the din is equal to the fout times the doubt. Okay? Which is what we found out before. That's easy. All right, good. Now we could rearrange this equation. And if we rearrange this equation, what we could do is we can divide both sides by d out and divide both sides by f in, and you get this equation here. And this equation is very, very nice. Okay? Why is this equation very, very nice? Because you're going to have this ratio. Now, I want you to go and notice, this is very important to understand, that the ratios are inverse of each other. A lot of times people, they just write it down and they get it wrong. They say the in and the out goes with the in and the out. That's wrong. The distance in over the distance out goes with the force out divided by the force in. And so don't make a mistake with that. Okay? Now, why is this ratio so very important? This distance in over distance out ratio? Well, it's so important because it is actually what is known as the ideal mechanical advantage. The ideal mechanical advantage is defined as the ratio between the input distance and the output distance. What? This is basically just going to tell you how good of a machine this is, how well it makes it so that you decrease the force. Of course, you're going to have to increase the distance to do that, but you're going to go and find out how good this machine is at helping people decrease the force. Okay? The IMA is going to be equal to the distance in divided by the distance out. Now, you can say the IMA is also equal to the force out divided by the force in, and that's fine. But you have to remember that what? This is without friction. With friction, you cannot say the IMA is equal to the force out over the force in, because friction is going to mess things up. There's going to be another force added to it, and that's going to mess things up. Even with friction, you can still say that the IMA is equal to the distance in over the distance out. But you can't say the force out over the force in with friction. Okay? So what do we do with friction? That's what our next video is going to be all about.